You may remember last class we worked on polygons, specifically recognizing that triangles, sure, they have 180 degrees, but quadrilaterals have more, 360, pentagons have more, 540. And as you work your way up with the number of sides in polygons, you get more and more interior angles, giving us this idea that if we take the number of sides minus 2 times 180, we can find the sum of the interior angles in any polygon. Today, we're going to talk about exterior angles in polygons. So let's do it this way. On top of that thing there. So when we've got triangles, we know that it has 3 sides. You guys are not copying this, you're just watching this. And that the sum of the interior is 180. And if the sum of the interior is 180, what's a single angle in a regular polygon? Regular triangle. 60, right? Now, we're going to talk about exterior angles today. Do you remember those from the remote exterior angle theorem? If I know that this is, for instance, 80 degrees, what's the measure of its exterior angle? Some of you may be trying to calculate what 360 minus 80 is, but that's not what the exterior angle is. This is the exterior angle. It's when you take one side and continue it out. So if I took one side and continue this out, what goes here? 100. In other words, the interior angle and the exterior angles are always a linear pair, so they're supplementary. So if I come back up here and I say that this goes out, this is 60 degrees here, how big is this exterior angle? 120. Good, 120. And if this were a regular polygon, all of these would be 60 and all these exterior angles would be 120, right? Single exterior angle. Now, how many exterior angles are there in a triangle? 3, right? So the sum of the exterior angles would be 3 times 120 or 360 degrees. You guys with me? When the interior angle is 180, the exterior angle is 360. What if we talked about a quadrilateral? What's the sum of the interior angles in a quadrilateral? Someone whispered it. Come on, you know, like a square has 4 right angles, so 360. Any predictions on what we get here? If this goes from 180 to 360, this would probably go from 360 to 720. That's a fair guess. Anyone have it? And what you're suggesting is that it doubles. Anyone have a different methodology that might get us from 180 to 360 and then 360 to good 540, where it goes up by 180 degrees more? That seems reasonable. Any other guesses? Is that enough? You guys feel comfortable with one of those? Okay. So in a regular quadrilateral, which is a square, how big is a single interior angle? 90. And if I were to extend that out to make exterior angles, how big would those be? 90 also, right? And in this case, I'm going to have how many of those exterior angles? So 4 times 90 would be 360 again. That's kind of cray-cray, right? So what about a 5-sided figure? What's the sum of the interior angles? 5 minus 2 times 180, 540. And how could we find a single angle in a regular pentagon? How many of them are there? 5. So 540 divided by 5, it would be 108. And if that's 108, how big is the exterior angle? 72 is correct. And so if 72 is a single exterior angle, how many of them are there in a 5-sided figure? There's 5. So 5 times 72 equals 360. So anyone want to make a prediction here or a hypothesis? Yeah, what do you got? The sum of the exterior angles in any polygon is 360? Wouldn't that be the best formula ever? It's just always the same number. But how can we be certain? We've done it 3 times. How many times should we do it before we're confident that that's the result? 10 times? Then you feel good about it? What if that 11th time was the one where it didn't work? Remember way back in the first week of school, we talked about inductive versus deductive reasoning. Using 10 times as a pattern of evidence. Is that inductive or deductive? Inductive. Is that a good way to do logic or not so much? No, we want deductive. So rather than choose any number, let's use n. What's the sum of the measures in an n-gon? It'll be a formula. Yeah. Excellent. N minus 2 times 180. And what would be the measure of a single interior angle in a regular n-gon? It's the process we did here. Now apply it here. Yeah.
N minus 2 times 180 over n.
Very good. And then what's the single exterior angle size then? What's the process we did up here that we could then do down here? This is the value of inductive reasoning, is we can create a pattern and a system and then apply it with variables to get a conclusive logical result. How did we go from 108 to 72? Same way we went from 60 to 120. Subtracting 180, right? From 180. So this one should be 180 minus n minus 2 times 180 over n. That's a bit messy in there. Let's clean that up. 180 minus n minus 2 times 180 over n. How can I clean this up? This is a whole number and this is a fraction, right? So can we make them both fractions? Now, what do you do with fractions? How do you add or subtract fractions? Good, make the denominator the same. In this case, we'd want an n. So I'll multiply the top and the bottom by n. And that means now I can treat it as one big fraction over n. And I'll distribute this 180 through. And then I'll distribute this negative through. These cancel. So I'm left with 360 over n. In other words, the single exterior angle is going to be 360 over n. And then what would then be, oops, sorry. What would then be the sum of all my exterior angles? How did I do it here? 5 times 72. Because there's 5 sides, which means 5 angles. If each exterior angle is 72, then all 5 of them would make 5 times 72 is 360. This is one exterior angle. How many exterior angles would there be in an n-gon? N, right? So n times 360 over n equals 360. Now we've proven it. Any polygon, if you add up the exterior angles, will always add up to a sum of 360. Let's put that into the notes. So on your note sheet, please flip to page 2, backside. It's up there on top of the yellow and black. So let's first fill in some of our formulas for before. The sum of the interior angle measure is what formula? Marshall, you said this one a minute ago. The sum of the interior is, or was it Tierney who said this? I don't remember. N minus 2 times 180. And then if we want only a single interior angle, the measure of an angle interior, we take that same sum and divide it by the number of angles, or n, which means we do n minus 2 times 180 over n. And now what we just learned today is that the sum of the exterior angle measure, what's the formula for that? We just derived it. It's a new type of formula for you. Does not require a calculator to figure it out. What's the formula for all the exterior angles in any polygon? 360. Which means if we want to find the measure of a single exterior angle in a regular polygon where they're all the same size, we're still going to take the sum of the exterior angles and divide it by n. But in this case, what would that be? (360 over n). So we'll come back to this in just a second. Flip back to side 1. If the exterior angle in a regular polygon measures 9 degrees, how many sides does the polygon have? So step 1 is figure out which of these 4 formulas you need. Are you talking about interior angles or exterior angles? In my case, black pen or purple pen. Exterior, right? Are we talking about the sum of the exterior angles or the measure of a single one? It's the measure of a single one, isn't it? They're telling us that a single measure is 9 degrees. So if the formula says the measure of a single exterior angle is 360 over n, then in this case, we'd have 9 degrees is 360 over n. Do you know how to solve that? Cross multiply. 9n equals 360. So n is 360 over 9, which is 40 sides. Any questions on that one? Okay, let's take a look at 17. Looking at this picture, would you say you're dealing with interior angles or exterior angles? Exterior, for sure. Are you dealing with a single measure in a regular polygon, or does it look like we're dealing with a sum? Sum. So what's the sum of all the angles in a exterior of a polygon? 360. So our first thing is to say 360 is the sum. Step two then is to say, okay, so what adds up to that? Just like we did last class. In this case, it's 5x plus 4 plus 4x plus 9 plus 9x minus 6 plus 4x plus 1 plus 7x plus 4 equals the total, which we said is 360. Let's combine like terms. 18, 22, 29. And 4 and 9 is 13, minus 6 is 7, 8, 12. Subtract 12. Divide by 29. And just got a calculator there. 48 divided by 29. You get 12. So x is equal to 12 in this case. This part of the unit is very algebraic, isn't it? Just make sure you set up the right equation. You got to use the right equation to start with and solve as necessary. Let's take a look at number 11. If the interior angle of a regular polygon measures 108, how many sides does that polygon have? Please take a moment and try to figure this one out yourself. Which formula would you need for that?
Yeah. Are you sure?
Okay, how'd we do? 5, that was easy. I got the answer, no problem. 3, I kind of cheated. I'll tell you in a minute how I did, but I know it's easy because of what I did. 1, I didn't know how to do it. Okay, how many of you just knew that a pentagon already has 108? You had seen that before. So 2 ways this can be done. One is long way. What kind of formula are we talking about here? Single interior angle. We said that the formula of that is going to be n minus 2 times 180 over n. And we could say that this measure was given to us as 108. So we could set that as the answer to this problem. To solve it, we'll multiply across, cross multiply. 108 n equals, I'll distribute 180n minus 360. Subtract negative 72n equals negative 360. N is equal to 5. But that's a kind of lot of work, isn't it? There's a much easier way. Compare this one to number 10, where you just basically took 360 divided by 9. That was easy, wasn't it? All right, you got an idea?
Yeah, the way I did it is I just said, I think this might be the opposite, but this I think this works too. I just said 180 minus 108 to find the exterior, which is 72.
Yep.
I just did 360 divided by 72. Since the exterior angles are going to equal 360, and that equals 5. So I got it as 5 sides.
Perfect. That's a lot faster, isn't it? Whenever possible, when you're dealing with individual angles in a regular polygon, try to use the exteriors because they're so easy. Just divide them into 360. So he said, I know that the interior and the exteriors are supplementary. So 180 minus 108 is 72. And then if I take 360 divided by 72, that tells me how many of those angles there'd be. The answer is 5. Yes.
Sorry, how do you find n in this equation?
In this case, it's there. And so what he said is, I'm going to look at this as though it's a polygon with an exterior angle of 72. Since the interior angle was 108, I know that they're supplementary. So I can discover this by saying 180 minus 108, get 72. And then if it's regular, where all the sides are the same and all the angles are the same, then all you have to do is say among the 360 that are around the outside of this thing, if each one of them is 72, I can just divide that by 72. And that tells me how many of them there are. Or you could just plug and chug, do the formula like I did here. The single interior angle formula. Plug in the 108 there, cross multiply and solve. Okay, one more to show you and then I'll leave you to your devices. Number 6, the sum of the interior angles of a polygon is 1620. How many sides does that polygon have? So which of the 4 formulas am I dealing with here? Interior or exterior? Interior. Am I dealing with the single angle measure or the sum? The sum. So what's our formula for that? And it gives us this 1620. Where does that belong? Is it n? N is the number of sides. Is that what they're telling me is the number of sides? Or are they telling me the sum of all the interior angles? So in other words, this whole sum thing has been changed to 1,620 equals n minus 2 times 180. Now I've got an equation with one variable, n. I have to solve that. Easiest way to do that would be to kind of peel off the onion layers to get at my n. Right now, this parentheses is being multiplied by 180. How do I undo that? What's the opposite of multiplying by 180? Dividing. So the next line is going to be 1620 divided by 180 is equal to n minus 2. And now I want to cleave off that minus 2. How do I do that? Add 2 to both sides. So I'm going to get 1620 divided by 180 plus 2 would find for me the value of n. I'll plug that into my calculator. And I get 11. This is an 11-sided polygon called a noondecagon. Some of you may have been a little surprised that I didn't actually divide 1620 by 180 and instead left it like this. The reason I did that is because up here we've got another opportunity to put in a formula. for the number of sides in a regular polygon. In the event that we're given an interior sum, we can use this formula. It's that sum of the interior divided by 180 plus 2. Take whatever they give us as the total, divide it by 180, and then add 2 to the number to get the number of sides. On the other hand, if I'm dealing with the exterior sum, no. Would I ever be given an exterior sum? Find the number of sides in a polygon that has an exterior sum of 360 degrees. Isn't that every polygon? So it'll never be an exterior sum, it'll be an exterior individual. And this is where we said if you take 360 divided by that, it equals the number of sides. Yeah.
What's before the XT, like exterior, what's that? Is that a 2?
You mean after it? Black or purple?
Oh, purple.
I said exterior sum and I crossed it out because we're never going to use sum. So it's the exterior individual angle. If you're given an exterior individual angle, you just take 360 divided by that to get n.
What's the one before XT?
E,
That's a-
cursive E.
Okay, cool, thank you.
Okay. All right, you've got the rest of the period to work on the rest of these problems. They take some